Hello guys, welcome once again to my presentation on research and statistics. If today is the first day you are coming across my video, please don't hesitate to check my previous video because you need to have a clear understanding of a number of topics that I've actually discussed before the most recent one for you to be able to understand the concept that I'm trying to actually pass across. So today we're going to be looking at a very important concept in inferential statistics. Of course, we understand that we have the descriptive statistics, we have the inferential statistics. Now, the inferential statistic is the one that helps us to draw conclusion even from the data we have actually gathered. So stick with me as we look at this very important topic. And the topic is Introduction to Hypothesis Testing. For most postgraduate students, hypothesis testing is something you have to really be familiar with. And of course, as a young researcher, or even if you're a final year student, because research is about trying to establish the validity of a claim, more importantly, the claim of the researcher. So we get right into it. Now, from what you can see on my slide, you can see an instance whereby a sample is obtained from a population to verify if the population mean is actually 50. Maybe a researcher has a prior information that the mean population age is 50 years. But the researcher actually feels that that may not actually be true. So what the researcher did was to take a sample from that population, and then he took an average age of the element of that sample, and he arrived at 20. Now the implication is this: we have 50, which is the default understanding. Now he got 20 from a sample. The implication is that that 50 becomes in doubt. So what the researcher would do is to reject the hypothesis that the population mean is actually 50. So essentially, when we talk about hypothesis testing, we want to test a standpoint based on the claim of the researcher. So, but what exactly is the logic behind hypothesis testing? Before now, I've discussed in my previous video what a hypothesis itself is, an unproven theory. Okay, it could be the position of the researcher based on his experience, his exposure, and he came up with a claim and he wants to establish the validity of that particular claim. Now, please understand that in hypothesis testing, we are not necessarily testing the null hypothesis. Our goal is to test the alternative hypothesis. In fact, the null hypothesis cannot actually be tested. You can only prove the validity of the alternative hypothesis, which is the position of the researcher. So looking at the screen, we have an example. Patients who take drug A have better outcome than those who take drug B. That becomes a hypothesis that a researcher may be interested in testing, maybe in experimental study, or he wants to test the concept of a new drug, or the efficacy of a particular drug, or even the effectiveness of a drug. So hypothesis testing involves trying to establish the validity of a claim, just like the example we have on the screen. But what exactly is the logic behind hypothesis testing? Now, if you look at the slide, you have a statement: I did not cheat, which is the position of the student. Now, an examiner, or call it an invigilator, took a position that the student did cheat, maybe in an exam hall. Now, the position of the student is what we describe as the null hypothesis. That's the claim of the student. While the position or the claim of the researcher, who is the instructor now, is the alternative hypothesis. Now, there's a philosophy in law generally that an accused is considered innocent until proven guilty. And that particular philosophy is central to hypothesis testing. Many a times when a researcher embarks on a research, he has a differing position that is putting forth a claim that he wants to actually validate. as against the backdrop of what has been known before. So the position of the researcher is the alternative hypothesis. The instructor is trying to make a claim that the student did cheat. But it is expected that when students go for exam, they are not expected to cheat. So he is the accused in that case, and the vigilator is the researcher who is trying to establish the position of a violation of exam conduct in this instance. So that is actually the logic behind hypothesis testing. Now, hypothesis testing is necessary to evaluate the result we obtain from a research. Usually, when we conduct a research, the usual thing we do is to take a sample from a population. In experimental study, you want to administer treatment to that particular sample. And after you have administered treatment to that sample, you now want to check individual, measure individual to see the effect of that particular treatment you have administered. Okay, so essentially in hypothesis testing, we want to check, evaluate the result we get from that particular research. So number one, in hypothesis testing, we want to rule out that there is no sampling error, which is what we describe as ruling out chance, that the result we obtain from this particular research, that sampling error or chance is not a plausible, is not a valid explanation for the result we actually obtain from that particular research. So hypothesis testing actually helps us to determine, in the case of the treatment I've just mentioned, if that treatment actually has effects even on the individual in that population. Okay, and usually we are always going to come across this funky looking kind of a curve, which we describe as the normal curve. And you have the treatment side, you have the untreated population, just like we have the treatment group, we have the control group in our research. So in hypothesis testing, if the individual in the sample are noticeably different, maybe after we have administered a particular drug, okay, trying to prove that the drug is better off than the existing one. So we want to check if we're going to have enough evidence that that treatment actually has effect. But however, it is also possible that the difference between the sample and the population is simply due to sampling error. There are times we conduct research, maybe because we didn't follow normal protocol, research procedure, we may get something that looks plausible, something okay. But in hypothesis testing, the goal is to establish if what we got is not actually due to sampling error, maybe little error from the researcher himself. So that is actually the concept of hypothesis testing. Now, if you look at the slide I just projected, you see the population there. Now, usually we say the average body temperature in healthy population should be 37 degrees Celsius. A researcher may decide to challenge that particular position, just like we have on the screen. And what the researcher will be saying at this point is that, from what I've observed about this population, I don't think that the average body temperature is actually 37 degrees Celsius. So, and then the researcher will come up with what we call an alternative hypothesis, which will be stated as what we have on the slide. The average body temperature is not 37 degrees Celsius. Now, of course, for every alternative hypothesis, there will be a null hypothesis, which is the neutralizing position, which is the position saying that we don't really need to change from what we have been used to. And that is what we call the null hypothesis. The average body temperature is 37 degrees Celsius. So when we do hypothesis testing, our goal is to test if the alternative hypothesis is actually valid, or we have enough evidence by which we can jettison the existing understanding that the average body temperature is actually 37. So what it is expected is that the researcher now too will normally take a sample from that population, and then he will take average body temperature of them. If you look at the slide, you have sample A. He took the first sample. Let's say he got 38 degrees Celsius, and he took another sample, he got 40 degrees Celsius, and he took another sample, he got 42 degrees Celsius, and he took sample D, he got 45 degrees Celsius. Now, the big question now is, at what point can we begin to doubt the validity of 37 degrees Celsius as the average body temperature in a healthy population or in a healthy subject within a given population. At what point? Is it at the point of 38, 40, and 42, or 42, or even 45? Now, if you ask several individuals, you are going to come out, you are going to get differing responses simply because it's going to be largely subjective. But the beauty of hypothesis testing is that it tries to give us a statistical standpoint by which we can see that the difference we are seeing is statistically significant enough to discard what we have been used to before. Okay, so that is why in statistics we talk about objectivity. Statistics tries to bring an objectivity into the concept of validating a particular claim. More importantly, the alternative hypothesis. Now, if you look at what we have on the screen, usually the general human will be the subjective perspective, while statistics will look at objective. It's like trying to establish a goal line by which you can rule maybe in a football match if it was a goal or not a goal. Okay, so hypothesis testing it helps us to actually decide between two possible explanations. The first is difference between the sample and the population can be explained by sampling error. While on the other hand, the difference between the sample and the population is too large to be explained by sampling error. In other words, there's a possibility of a significant change in what we are actually observing. So, but in hypothesis testing, after we have established our null hypothesis and the alternative hypothesis, there are basic things that are required before you can conduct an hypothesis test. Okay, the first, you need to establish the critical region. The critical region is just like the position by which you can determine, just like in the example of the goalpost and the illustration on the goalpost I just made. So you have the critical region. You also have the alpha level. The alpha level is synonymous to the p-value we said, p-value of 0.05, by which we can rule if our null hypothesis should be rejected or we should fail to reject it. And of course, the last is to determine the test statistic we are going to use. For every statistical, for every data, there are appropriate statistical tests that actually flow with the given data, depending on also what we try to achieve in that particular research. So we have seen the example I mentioned earlier. In the case of sample A, sample B, sample C, at what point, maybe at the point of 42, some people will feel, well, there's a significant difference we can see. But statistics will help us to establish at what point can this difference be considered actionable, with which we can now discard the existing position. So, and the critical value we are talking about that I just mentioned is establishing the point under the curve. This funky looking curve is central to inferential statistics. So when you have this particular curve, the unshaded portion of the curve is the non-rejection zone. So when our test statistics actually falls within this particular region, okay, we call it non-rejection zone. This is the point at which you can say, well, there's really no difference from what we are seeing. While you also have the rejection zone, which is the shaded portion, we call it the rejection zone. So when you have your test statistic, after you have calculated it or computed it, if it falls within this particular shaded area, it is a time to reject the null hypothesis, saying that, well, the data we have is consistent with the fact that there's a significant difference in what we are seeing in our data. Now, there are 6 basic steps by which we can test hypothesis as a means of summary. Number 1, we have to state the hypothesis. We have 2 types of hypothesis, the null hypothesis and the alternative hypothesis, which is the position of the researcher. Number 2 is to determine the alpha level. We must set an alpha level before we start a research. We usually describe it as the p-value, and p-value of less than 0.05 is the conventional. Okay, while the third step is to locate the critical value, and then we compute the test statistics, and then we want to draw conclusion based on the level of significance we have established, and then we have an interpretation of our findings. Pretty interesting, right? So thank you very much for listening. You can appreciate the fact that statistics, a basic knowledge of statistics is very, very important for every researcher because it is the language by which we communicate research. You may not really have to be an expert in statistics, but you need a working knowledge of statistics. Now, if you stick with me in on this particular channel, you subscribe to my YouTube channel, I can teach you step by step on how to make sense of your data, how to analyze your data, and how to present your data effectively, even for international audience or even for publication. Thank you very much. My name remains Dr. Felix Ayodele Yeleye. I will see you in my next class.